All right, so a six-sided die has these numbers and it has an expected value. Do y'all remember what the formula for expected value is?
No.
Or how we find the expected value?
Also no.
This is your unit.
Yeah, n times p.
Yeah, so you are multiplying the probability times each individual option, and then you are setting it equal to your expected value. So in this case, we know our expected value. We know our expected value is 5.5. And we know that it's going to be equal to all of these things added together. Or, sorry, let me rephrase. What's the probability of rolling any side of a die? 1/6. So I'm going to have 1/6 times each of these options, right? Now I could write 1/6 times this plus 1/6 times this, but I know that multiplication is something that I can pull out. So I have 1/6 times 9 plus 5 plus 6 plus x plus 3 plus 4. Once again, this is a paper one, so there is no calculator. You have to do some math. Oh. So I have, I'm going to do 5.5 times 6. The way I do that without a calculator is I'm going to do 5 times 6, which is
30.
Okay, and then 0.5, 1/2 times 6 is the same thing as 6 halves. 6 halves is the same thing as 30 plus 3 is
33.
So I have 33 is equal to, now I'm going to add everything together except for the x. 9 plus 5 plus 6 is 20, plus 3 plus 4 is 27. So then I get that x is equal to 6. So that's part A. Everybody good on that? Any questions about that one? Go ahead.
So what's the difference between that and like when you multiply down like that's equal 1? Is that like a different thing?
When you multiply it down, it doesn't always equal 1. When you multiply down and add across, it equals the expected value. The bottom row of probability should always equal 1. So 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6.
What multiplying down thing?
Okay, so typically, if this were not a set probability, let's say it's a loaded die, meaning one side is more likely to happen than another, we would make a probability table. So we have our options, and we have a probability here. So in this case, it happens to be 1/6 for all of them. So I have the number 9, and the probability of that is 1/6. And then I have 5, and the probability of that is 1/6. So on and so forth. And so you multiply down, so 9 times 1/6 plus 5 times 1/6 plus 6 times 1/6, which is what we're doing here. I just pulled out the times 1/6 because it's the same for all of them. Cool? Okay. Moving on. Determine the probability of getting a sum of 12 when rolling the die twice. Now, when I roll a die twice, how many potential outcomes are there? 36. There are yes, there's 6 options and 6 options, but the number of combinations of those is 36. So I know that this answer, sleeves, guys, is going to be out of 36. So that's one step, one thing I know. Now, how many different ways with 2 die, because remember it's not 1 through 6, it's these numbers. And we found that X was 6 right here. How many different ways can I make this add up to 12? So I have 9 plus 3.
And then 6 plus 6, and then 6 plus 6 again.
And then 9 plus 3.
There's 2, so
So there's just 4 total.
and then
There's only 3.
3.
The reason why is because there's not 2 options of 6 plus 6. There's only 1 option of 6
but
plus
it
6.
just has a greater probability.
Oh, it's like the same dice twice.
You're rolling the same die because it's just one 6-sided die. Y'all are thinking if I was rolling 2 die, but this is the example where you would have the big box. But if I have a 6 and a 6, there's only 1 box there.
Oh.
The order matters except for when the numbers are the same. Because if I say I rolled a 3, then a 9, that's different than me saying I rolled a 9, then a 3. But if I say I rolled a 6, then a 6, that is the same thing as me saying I rolled a 6, then a 6, even though in my head I rolled a, does that make sense?
Yeah.
Because I'm not saying the word and, it's then. Okay. So I have 3 out of 36, which simplifies to, that is the probability of, that they asked for.
We got 36.
So there are 6 die, there are 6 options on a die. And so you would make normally the big table with 6 options. Or you could do counting permutations, however you want to think about it, but we just know that one, that there are 36 boxes, 36 different outcomes.
How are we writing in the test? Like, are we just writing 3 over 36?
Yes, for that one, because it says determine, you don't have to explain it. You can just write it. For example, on the mark scheme for this one, when we're talking about rolling the die twice, that section where I wrote 9 plus 3, 3 plus 9, and 6 plus 6, that is a mark, but it's one that's an optional mark. It's implied if you say 3. But if you wrote 4 out of 36, but didn't show your work to say 9 plus 3, 3 plus 9, 6 plus 6, 6 plus 6, you would not get partial credit for it. Does that make sense? I don't even know that they would give you partial credit, but you're definitely not getting partial credit if you mess that up. Make sense? Okay. Moving forward.
The table is just like writing out all the different.
All the different options, yeah. Okay, here we have a little bit of an abstract question, but it might help you to come up with your own number set if that's the way your brain works. We have the mean of a set of data is 4.3 and the standard deviation is 1.4, right? The new mean and standard deviation if every number is increased by 4. So I can show you guys with math, but does anybody have a first instinct? Go ahead.
Idea. Would it be, based on the standard deviation of 1.4, you add 1.4x, and then you could do 1.4 now.
Go ahead.
Could you just have like 3 numbers, one's like 2.9, one's 4.3, one's 5.7, and then just move it like that?
Sure. Okay, so when I add 4 to each of those numbers
Well, nothing changed.
and then recalculate the mean, what would the mean be?
Wouldn't it be the middle number with added 4?
You're adding 4. Your average, if I increase every number by 4, then the average is also increased by 4. So when we're adding, it's increased by the same number. But let me show you some of the math behind like a generic proof. Now, Rohan proved it using specific numbers, but if we go back to those of you who were in HL proofs, and even those of you in SL, you should know how to do a basic proof. What is the concept of a mean? Like, how do I find that?
The sum divided by
Okay, it's the sum of numbers divided by the set of numbers is equal to, we know it's 4.3, right? Okay, so I could say that the sum of the numbers is equal to 4.3 times the number of numbers. If I increase every number by 4, how does that affect the sum?
4n.
One that,
Okay, the sum is the same thing. It's going to be the same number, the sum, the original sum, plus 4n. Do you want to explain how you knew that now?
Because every number, it increased by 4, so for every number, I don't know. is it-
For every number there is in however many terms we have, like if there's 7 terms, if each term increased by 4, how much did I add? I added 28 to the overall total. Does that make sense? Everybody get there? Okay. Is equal to 4.3. And using this same concept, I can solve and see that the sum, the only thing that changed is this 4n, but when okay, how do I say this in words? When I divide by n, you just know it, guys. So because I'm dividing by the same number of terms, you've increased the mean by that much. I just shifted my set of data for this way. So the average is just 4 more. Does that make sense?
yes.
So from the similar concept, what is a standard deviation? It's the spread between the numbers. If I take this spread and I increase it by 4, did I change the spread of numbers?
No,
So the standard deviation, when I increase it by 4, stays the same.
but when you multiply by -2, it changes.
We're almost there. But you got it. Does that make sense? Okay, go
How
ahead.
do you write, like, you just write like the little symbol for the standard
I
deviation?
do, yes, standard deviation.
Wait, is.
So our mean would be 8.3 now. And our standard deviation stays the same for the first one. Our second one is when it's multiplied by -2. Now, Mikkel, you were telling me that it changes. How does it change?
Because the spread is now different because multiplying every number by -2, right?
So every number has multiplied by -2. So let's think about if I have the number 1 and 2. What is the standard deviation? What's the spread between 1 and 2?
1.
Okay, when I multiply those numbers by -2, I now have -2 and -4. What's the spread now?
-4, -2.
It is just
2. My spread is doubled, right? Now pick any 2 other numbers and think about their spread. Okay, so we had 5 and 7, the spread is, okay, when I multiply them by -2, I have -10 and -14, the spread is now. In this case, it also doubled. So my standard deviation, when I multiply by 2, will double. I have 2.8.
Are we including the negative sign?
You would not, the spread is
Oh, it's
not
the
a
same.
negative concept. What about my mean? How do you guys think it's affected?
It's gonna become negative, right?
It is gonna become negative, because all my data like flipped, it's all now negative. What else? It's gonna multiply by 2. So now I have -8.6. Any questions? We good? This is an example of one of those abstract problems. It's a lot easier to think through when they give you the numbers, right? If they don't give you the numbers and you're struggling to think through the abstract nature of it, give yourself your own numbers, see what it does. Okay? All right. All right, next, yay. Okay, so frequency graphs, switching to box and whisker plots. So we are going to take these cumulative frequency graphs and turn them into box and whisker plots. It's a little bit of a weird concept, but once you get the hang of it, it's not too bad. I can't put all of them up on the screen. So look at all of your box and whisker plots. 3 of them will match these up here. Okay? You think you know, Tomas?
Oh, no, is there a reason why there isn't a fourth, or is it just because like
Look at the next question. Go ahead.
I have one that I think matches.
Okay, what do you think matches?
The first one's B.
It's the third one.
I think the easiest one to match is which one is B, and you said it's which one?
The third one.
The third one. Do you guys see why it's the third one?
Yeah. Oh, I see.
It's a little tricky, the concept between them, but you can add lines that represent the quartiles. Remember, the quartiles is like 50% of your data. So here's like 25% of my data. These are all terrible lines. So 5% of my data and all of my data. If you were to move these points where they intersect the red lines into one straight line, you can create a box and whiskers plot. That's how you do it. So here, this one, when I divide it into fourths, it's increasing in equal increments. Do you guys see how the box and whisker plot is equal fourths? For the third one, that's why it's B. Okay, so using that same concept, can anybody identify a different one?
second one is B?
The second one is not D.
It would be A.
The second one is not A.
Is it C?
Well-
It is C. Let's talk about why. So for this one, if I were to take my lines, I'm just eyeballing my like half. Quarter, 3/4. These are a little bit off, but hopefully the same principle will apply. So I have these points. If I were to hit them with some color.
Okay, so you put all.
Do you guys see how these points are here? Then I can create a box and whiskers plot. I didn't do a very good job. That's supposed to be a line. I think. Do you guys see how the line at the beginning is the longest? Like it takes me longer to get up to 25%, but then it starts increasing more rapidly. When I say the word increasing, what word does it make you think of? The slope. And if I'm talking about the rate of the slope, calculus, what is that talking about?
Related rate.
Yeah, what is the derivative of the slope? What does that get me to?
The gradient.
It's the concavity.
Oh, right.
So now I can look at the concavity of each of these to see how much they're spreading out.
For sure.
But I can look at the concavity of these, since this is concave up, and it's like increasing slowly, the rate of change there is not as steep, meaning that it's gonna be, it takes me longer to get up to that 25%. So my first block is gonna be longer, and then they get increasingly shorter. Go ahead.
Do you redraw like how you got the box and whisker? Like, I was
Yeah,
confused.
Okay, so I just moved, the first thing you do is you get your 4 lines as close as you can. Whether that's eyeballing it with glue, whatever. I moved my dots, like where they intersect the function itself. And then I moved them up to 1 line. So I just put them in the middle because it was easier. So here, here. I just like shifted all those points to the same line.
Oh.
And then you have line, box, box, line. Okay,
So the first box is the bottom line, right?
The first box is the distance between the bottom line and the second line. The first line is between the origin or the y-axis and your first dot. Okay, we have one left,
A
50% shot,
is 1.
A is 1. Can you talk about how you know?
Yeah, so, we see that like the middle two are like smaller,
Uh-huh.
and on A, we can see that it's like can I come up there and like?
Yeah.
So,
Here, and here is more than like the two areas.
I also look at here in the middle where he's talking about the slope is pretty close to this straight slope, right? It's pretty constant for those middle two, and these middle two are the same way. You can also look at the concavity changes from being concave up to like neutral to concave down. Go ahead.
Okay, maybe I'm crazy, but like when I draw on my sheet, they all kind of just like look the same size.
I will say that that's also because of how small these are. Like when I zoom in and like make them bigger.
But will they be zoomed in?
No, you would probably get a question like this. So
That's what
you
I'm
can't,
saying.
so I also look at the concavity is what helps me. So when I go, this one's the easiest to identify because it's straight, meaning all the pieces are gonna be the same size. Here I go concave up, neutral, concave down, meaning increasing, neutral, decreasing. Or well, the opposite, sorry, decreasing, neutral, increasing. It does the opposite of concavity. So I have big, same, big. Make sense?
Yeah, I get that, but I just like, when you write it out, like with C, the concave is just like up, so then I would know that the middle is C.
So once you did your fourths, this one to me, it's like, I know that it's increasing slowly, right? At the beginning, it's not as steep.
Mm-hmm.
So that means that it's gonna take me longer to get there. So that means that my first line needs to be my longest.
Okay.
In my box and whiskers box. Okay, so now the only one that we didn't use was
D.
So now we're gonna reverse engineer that concept. What would my box and whiskers plot look like?
The left being larger than the.
Okay, the,
other way around.
Other way around.
yeah, the right has to be the longest.
Yeah, and so I think, wouldn't it be even for the first three and the last one just be bigger than them?
That's where it's a little bit harder to see. I get where you're saying, even, but technically, I know this looks like it's straight. But really, it's more like the opposite of this one.
Delightful.
Does that,
So we just draw an opposite
Let's see.
box and whisker part?
so the first line should be 1 dash, and then the first box is 2 boxes, the second one is 3 boxes, and the last one is 4 boxes.
How do you
Like
know?
it's constantly increasing,
Oh boy. You said,
constantly concave
so
down.
1, 2, 3, 4. You said for the boxes.
So like 1, 2, 3, yeah.
I didn't know how big.
Not
two-
for Steve, right?
So I just filled
That's
the
right, that's
box.
the thing.
Okay.
Wait, oh. I don't think I did this.
Okay, so your first box needs to go out that far instead.
Are
Okay,
they
how do we
equal?
feel about
Are
that?
they-
I know that was weird, sorry about that.
Are they equal?
No, so the first line is only 1 box long. The box is 2 boxes long, and this one is 3. Like, so on your paper, there's like, yeah. Okay, how are we feeling?
We're done.
Okay.
It could definitely be worse.
Okay, so for the drawing of that one, was it you, Mikkel, who said you think it looks consistent for the first 2? Okay, something that I noticed is because this last one is like super sharp, right? Meaning it has to be the biggest. Do you think it's bigger than the one next to it? Like the one to the left, like the next box over, do you think it's gonna,
Yeah.
okay. Do you think that one right here is also bigger than that one? Like the gap, the X gap is bigger than this?
I'd say so.
So because I know that they're all decreasing, then I can divide up my boxes to figure out how much they're supposed to be. That helps me identify that the first two aren't the same.
Alright.
Okay, the next one, 6 friends ordering drinks of Coke. Diet Coke and regular Coke, the waiter gets them mixed up. One person is designated to taste all the Cokes, clearly not during COVID. But so they're drinking, they're tasting each one to identify which one is diet and which one is regular. Is that your question?
No,
There's just a blank page in between.
Okay, yeah, gotcha. Okay, so explain why the sample space is 1, 2, 3.
Because it's either Coke, not Coke, or
Because,
No.
it's just 3 drinks, right?
no,
There's
there's
6 drinks.
6 drinks, but there's 3 of each.
Okay, so what are the different scenarios? That's what I would do to explain
So-
this one.
so-
So the first scenario is,
They drink it and it's Diet Coke.
so the first one is like first try, it's Diet Coke. Okay?
They drink it and it's regular Coke.
Okay, so then I could try regular Coke, and then what happens? Okay, and then I get Diet Coke. What's another situation that could happen?
Regular.
I could get all regular.
Right.
But if I get 3 regular, what does that tell me?
The other one.
The other 3 are Diet.
There's one more. You're missing one.
All diet.
2 regular, 1 Diet.
Huh?
And then 3 diet, right?
Wait, did you?
Well, no, just it's until they find one.
Until you get one.
Oh, in that case, it would be regular diet or diet. and-
No, just they stop once they find a Diet Coke. This is the probability in order to find a Diet Coke, not to identify all 3, just to identify one Diet Coke.
Why would they?
Okay, but we know that there's.
Why would they do that?
Then it would be
Bro,
one
that's
diet
not a
Coke.
problem. They're
It'd
just
be
trying to
regular-
find the one.
Wait,
They just need to find their Diet Coke,
Can I
What I'm
write it?
saying is you, we
and
know
then somebody
that,
else takes over.
we know that
Can I
there's
write it?
No,
3 of each.
Uh-huh.
So we have to find one where there's at least one.
no.
Yeah.
Can I write it? Like, all of them?
I told you.
Okay, those are our only combinations. Okay? So that means I get it on the first try, it takes me 2 tries to find it, or it takes me 3 tries to find it. Okay?
Yeah.
Alright. So now the next thing is determining the values of X, Y, and Z in the table. Alright, so in this instance, I have these drinks in front of me. Jacqueline said it first. She said you either get Diet Coke or you get regular Coke. Like the first cup I take, I have a 50% chance that it's going to be diet or regular. If it is Diet Coke, I'm done. I don't have to do anything else. If it is a regular Coke, I'm going to pick another cup. What is the probability that it is a Diet Coke?
3/5.
Go ahead.
3/5.
Why is it 3/5, Joaquin?
Because there's 3 diets, but you already found out that one of them is not diet, so there's 5 out of 6 left.
So I only have 5 options now instead of 6, but I still have 3 Cokes remaining. Okay? All right? Something that I know, you can do this one of 2 ways. You can either think through the pieces, or I always know that this bottom row of probability is going to equal, so I can do 1 minus 1/2 minus 3/5 equals Z, or you could think through your options.
Wait, what's the option?
What?
If you did your option way, it'd just be 3/4.
I want to say no. Okay, hang on. First, finish this one with me. So we have 1/2 minus 3/5, 6/10.
1 minus 5/10 minus
That's
6.
not
Wait
minus-
a minute.
Wait, no,
Wait, 1 minute.
Wouldn't it be 1/2 plus 3/5 plus Z equals 1?
Yes, but then you just flip it.
That's what I just
That's
did.
what you do with it, if you flip it, bro.
Oh, yeah, you're right.
Yeah, because we're gonna isolate the variable.
Just think it through, bro.
They have one.
I got it.
Wouldn't it be easy to just think it through?
Yes.
I'm stressed. Why are you getting?
You can just tell our elite sense of humor from that.
No.
What are you doing?
I was playing this before, I think.
The what?
Good help for you guys.
My answer key. What?
Why is that
I'm so crazy, okay.
Okay, the answer key has 3/6. Y should be 3/6 times 3/5.
Wait a minute.
Wait, what?
Oh, okay.
Oh, wait,
I got it. Okay, so you remember how I said you have to go through the pathway?
No.
Yeah.
Okay, so we have to make, okay, so the first time you either have a Diet Coke or you have a regular Coke, right? And then you make the second pathway from the regular Coke to be a Diet Coke. So here we have 1/2 times, and this probability was just 3/5, but we have to have both of those options happen.
There's something I can't erase. I wrote it in pen.
Scratch it out, it's good practice. I'm sorry.
Wait,
This is why you don't write
I
on
understand
the
everything you
slide.
just said, but what does that change?
Okay, so then because it's like you have to have both events happen, that's the combined probability, meaning you have to multiply the two. So it would be 1/2 times 3/5 would be the probability of Y. So here would be 3/10.
Is it just like the probability tree?
Yeah,
No.
and then we have 1 minus 1/2 minus 3/10. That's why it's easier to do this method than going through the probability tree, because there are 2 branches with 3s, and you have to do both of them and add them together. Woo, guys, it's basically Monday morning. I know it's Tuesday.
Is it one fifth?
It is Monday morning.
Okay. So from here, you should end up getting that 5/10, so 2/10, which is 1/5. Right? Did I do my math right in my head?
Wait, so
I did.
So why is it, oh, okay, okay.
Everybody good?
no,
Okay.
wait, not yet, not yet, not. Yeah.
You do the probability tree, so you do 1/2 times.
Oh. Okay, so we have 2 events and both could happen. So we have to get a regular Coke and then a Diet Coke. So it's the probability that I get a regular Coke times the probability of 3/5 of getting a Diet Coke after that. So then the combined probability would be 3/10, and then you plug 3/10 in the formula, solve for Z.
Okay, I can. Maybe don't do it.
Part C is determining the expected value. How do I find the expected value?
P times N.
N times P, but that's just if they give you a probability and a number. But like, what do I do when I have a table like this?
Multiply.
Multiply all of them.
And then
And
add them together. So I would have 1/2 plus 2 times 3/10 plus 3 times 1/5.
Is this B?
This is B. B was the 1/5 part.
Right.
Okay, so I have 5/10 plus 6/10 plus 6/10, 17/10.
Do you make it? Do you-
1.7 is also acceptable.
Do you have to put in fraction form or just? like-
1.7 is also acceptable. I would just be careful with expected value versus probability.
Where did the 3/10 come from?
That's our answer to part A, once we fix it.
Okay, so
And then part A.
it's the first
We did
probability.
1/2
second
times
probability.
3/5.
We did it. Oh,
Yeah.
okay.
Okay, moving along. Slowly but surely.
Wait, what did you guys do for that?
Okay, so they reserved their tickets and they're located near each other. We're looking at which seats they would sit in. We have to fill in these blanks. This one should be easy points, I hope. So I'm gonna let y'all try it first. So here are the option choices. If she sits in her own seat and Mark sits in his own seat, then Leanne would only have one seat left, which is her own seat. Does that make sense?
Yeah.
Okay, so what if she sits in Mark's seat? Whose seat could Mark sit in once his seat is taken?
Yeah. Or Takuna, or Mark could just help Takuna.
T. Takuya. Or Tomas said Leanne. So here I'm filling in Leanne. If Mark sits in Leanne's seat, then whose is the only seat left for Leanne to sit in?
That's a cute name.
All right, there's one option remaining, meaning that if Takuya sits in Leanne's seat, whose seat would Mark sit in?
Wouldn't be 2 choices?
Wouldn't you sit in Mark's seat?
That's already an option.
There is only one option. Go ahead and say it again.
Mark's seat,
Why is Mark's seat the only option?
because it's his seat.
Because he's gonna.
That's right. No, it's because your options here are already taken.
Oh.
Like there's not,
Wait a
Two
minute,
options.
what?
This is just the way this is set up.
I know, it's a very bizarre setup. That I was like, I have confidence in your abilities to get the second one. I did not have
Wait, why
this high of confidence in your ability to get the
Thank you. I don't know.
why wouldn't that be a 50-50 there? Like a second option?
Because it's,
Because it's his seat, it's reserved for.
because the other combination is already taken in
Oh, so-
this.
So our repeated probability doesn't
But how
matter
does,
anymore.
how does that make why?
It just.
It doesn't make sense. But wouldn't this combination be taken already in the first place?
No, because.
Because
Leanne
what?
and Takuya's-
Yeah, but is the second one Mark's first?
Yeah.
Why does this make sense?
Yeah, no,
It does.
It does though, it does, it does,
Doesn't
it
make
does.
sense.
You literally are the one who said you just.
Yeah. It doesn't make
You said
sense.
that.
There, that sentence. Mark is to sit down next, sitting in his reserved seat if it is not already taken.
That's what I said.
Oh,
because it must be
okay.
else.
I just didn't interpret it the way you said it. I got you. All right.
So the reason there's a split there is because there's an order of people sitting down, so
It's
if
Mark's
Mark,
seat,
bro, Mark's gonna sit you
Shut up. No, that's literally the answer.
All right,
You see it in the first one. It's
So-
literally the first one.
Well, what is the probability? It is the first one, that's right. What's that probability?
Yes.
The probability that all three of them sit in the correct seat is 100%.
1/3.
Wait,
What? Dude,
Someone
wait a minute. Wait, if the probability that they sit in their own seats is 100%, then what's the point of the rest of the chart?
Thank you. Go ahead.
It's 1/3, right?
Why do you think it's 1/3?
Because after Takuya sits in her own seat, then Mark is gonna sit in his seat, 100% probability, and then Leanne has to sit in her own seat as well. So 1/3 is the only thing that's relevant.
What do you think, Rohan?
wouldn't it be 1/6, because Mark's going to 2 seats to sit, so it could be 1/3?
No, because
Mark
Mark's
has-
gonna
Yeah.
sit.
Yo, so same
I think
thing.
it's 1/4.
No, you're wrong.
Rohan, if Mark's spot is available, he has to sit in that spot.
Yeah.
So,
doesn't have to.
what did you say, 1/4?
1/4.
The correct answer is Thomas's answer, 1/4.
Okay, yeah.
One-third.
Is that it?
You said
If
1/3.
Mark's seat is available, he has to sit in that spot. He doesn't have a choice. Making that strong.
Okay,
Mark
so
Dawson
the
is-
only option, the answer I was listening to hear from you was actually Andrew's answer, because it was the answer that I initially gave. Like I was tricked by this problem. The reason why is because there's only one pathway where that works, and there's 4 different pathways, so in my head, that probability was 1/4. But it is conditional probability because it works on the person in front of them. So the pathway that we're looking at is the idea that there's a 1/3 probability that she will sit in the correct seat. If she sits in her seat, Mark has to sit in his seat, meaning that there's a 100% probability that if she sits in his seat, and if the first person sits in the correct seat, the second person has to sit in theirs, meaning there's a 100% probability. Meaning the third person
Doesn't
has
have
a
a choice.
100% probability because they don't have another option. So it's 1/3. But I went through the steps of why, because remember that because we're moving down a pathway, you have to multiply. So technically we're doing 1/3 times 1 times 1. Does that make sense?
Yes.
Yeah.
Why don't they just sit in
I
their
didn't hear
assigned seats?
BI, I heard BI, and I was like, are we talking about over the body?
Is this the paper?
What?
Is this one? No, I'm asking, come on.
Okay, next.
This is, there's.
Find the probability that if Takuya sits in Leanne's seat, given that Leanne does not sit in the correct seat. I was looking at this problem earlier and I think it's important, but I'll roll with it. Yeah.
Wait, if Takuya sits in Leanne's seat, doesn't that automatically mean Leanne will sit in the right seat?
It's
But what if
conditional
Mark's not there?
probability.
What?
Okay, using their mark scheme based off of the conditional probability formula,
Wait, doesn't that have to be?
Leanne sits down last.
I think they wrote it backwards, guys. So let me double check real quick because it says, the conditional probability formula. The intersect of A and B divided by B.
Is it 2/3?
It is 2/3.
Why would you-
Do you want to explain it?
Yeah, I think so.
Okay.
So
Good job.
there's 3 seats, okay, Takuya, Leanne, and Mark. Okay, so Takuya sits in Leanne's seat. So there's 3 different probabilities that could happen. Leanne could either, wait, hold on. Let me try to.
Doesn't Mark come second?
Mark could be there, or Mark couldn't be.
He sits down first. He's not gonna be anywhere.
So this is why I think it's written backwards. I think what the question is meaning to say, given that Takuya sits in Leanne's seat, find the probability that Leanne doesn't sit in the correct seat. But that also would make sense because that would just be 100%.
Yeah, because Mark's gonna sit in his
There's
seat.
still
He
a
comes
1/3
second.
There's
probability.
something up there.
Like the bottom thing.
Doesn't Takuya sit down last?
No, there's two thirds, sorry, okay. So here, there's two options, so if,
Oh,
no,
Mark is
because
coming.
that's.
Mark sits down second, and he's gonna sit down. And then Leanne's not gonna.
I know, guys.
So it's gonna be 100.
So, well, isn't this?
Never say 100%. And you're not going to.
Freak you.
I think, okay,
Isn't it
They use the conditional probability formula. When they use the conditional probability formula, so it's the intersect of both events happening divided by the probability of the second event happening.
What's the intersection?
So the intersection is and, meaning you multiply the two together. So the, birds or, anyway, the combination that they have here is 1/3 divided by, 1/3 times, I'm gonna write it out,
This,
and then we can.
I just think this whole thing just wouldn't happen. The whole scenario, because Takuya is supposed to sit down first, and then Mark, and then Leanne's last, so she never gets to pick where she's gonna sit, right?
Right.
This is why.
And so, you know,
No,
If-
there's
if
one
Mark-
scenario where Mark isn't there, it's just Takuya and.
so
Leanne.
Mark just doesn't exist, there's no
There-
Mark.
no, there's one scenario.
Stop it.
Leanne would get there before Mark.
But that's
There's
not
not
possible,
really
because
really
the overarching, like, the question states, Takuya sits down first, choosing a random seat in which to sit, Mark sits down next. It tells you the order in which they sit down, so it literally can't happen.
That's not part of the question.
It is.
Yes, it is.
It is part of it.
It's part of
Read the paragraph.
But this is the work that they show here. It's 1/3 divided by this. I think that what they did is that they should have said that if she didn't sit in the correct seat, not in Leanne's seat,
I tried turning it off, but it didn't work, I'm sorry.
because I think they're talking about these two pathways instead of one pathway. I think they just misworded the question.
So if you're
I could be
taking,
wrong, but
well, wouldn't that mean you have to take the 3 pathways? Because if you're taking into account the bottom of the other one, you have to take into account the
This
top
is
of
like the
other
Monty Hall problem.
no.
The what hall?
Well, I mean, sort of, so like that was kind of thinking that someone else is picking it up.
no, because the question says, yeah, you're right, but,
It was a 50-50 flip.
Can I just skip this one?
yeah.
Oh, it's, what Mrs. Cobb?
Is that where you?
I will look at it and see if I can find something, and then I'll bring it back to you, okay? 8, the probability of a biased die. If they give you the expected outcome, we have to find A and B. This is a systems of equations problem. What are my two systems that I can set up?
The bottom row is equal to 1.
The bottom row is equal to 1, so I'm gonna add all of these things together and set them equal to 1, so that's 0.8. If y'all don't mind me doing algebra in my head, I hope. So I'm adding the bottom row together. And it should be equal to 1. So now I have A plus B equals 0.2. Okay, I have a second formula. Go ahead, Rohan.
If you like do the expected value, you get this equal to 3.1, right?
Okay, so I also have that 3.1 is equal to 0.2 plus 2A plus 0.45 plus 0.64 plus 5B.
Wait, would it be 0.16?
That's what it meant, not squared.
What did you?
Yeah,
So what was that? You said 0.1.
0.16.
We're saying same thing.
Oh my god.
0.16.
1.6.
Isn't it 1.6?
1.6. I just,
0.16 and 0.16.
I could say 0.16.
Oh, yeah, 1.16.
Everybody be.
Oh.
So you were all
confused.
wrong.
I was like, Rohan, what are you saying?
okay, I have two formulas. The first equation, you solve it for A or B, doesn't matter which. Plug it into the second formula. That way you only have one variable to solve for. Once you solve for that variable, you plug it back into the first equation and that gives you your second variable. Is that, systems of equations is something that y'all learned a while ago. Do I need to sit here and do the algebra for you?
No.
Okay, so the final algebra should give you,
Don't worry about it. No calculator.
A is 0.15 and B is 0.05.
Right.
Who's for 7?
B is what?
0 is 0.15. B is 0.05. Those should be the final answers that you get after you solve those equations.
What?
A
Point
is
0.05.
0.15.
B is 0.05.
Thank you so much. I hate when people.
And if y'all need to repeat that one more time.
0.05.
Absolutely not, sir. Don't bring me answer, guys.
Like when people say 0.05, I just say 0.05.
Right.
Oh, yeah.
Zero,
Annoying,
one,
like-
fifteen,
I write my
And then
zeros
one,
out. So far.
1.5, B,
You know what?
64.3.
No, it's 0.0.
All right, this next one is super duper easy.
Thank you, thank you.
Ooh, yeah.
It's just shading. So here, the question is
The first one is shaded.
Greater than 1. So I find 1 and I shade where it's greater.
Color, yeah. I do love coloring.
Okay,
This is 5 marks.
this second one,
Ms. Alvin, can this be on our?
the second one has the absolute value of Z, your Z score being less than 1. Where should I shade?
From 1 to the very end.
Incorrect.
Got an absolute value, guys.
But it's the
It's just
absolute
1 and
value.
0.
so
It's
anyway.
between 0 and 1.
Value is positive, right?
It's gotta be
It's
positive.
between 0 and
Absolute value.
Okay, between 0 and 1, I heard that. That part's right.
Okay.
Oh, yeah, and then -1.
Yeah, and then it's between -1 and 0.
Between -1 and 0. Why? Think about a number
Can't be greater.
between 0 and -1. So let's say -0.5. When I take the absolute value, that becomes
Like 100.
Oh.
0.5. Is that less than 1?
Yeah.
Yes. But if I were to take -2 and take the absolute value, that gives me 2. Is 2 less than 1?
No.
So I should not be shading on this side of the
I got a question.
All right. Moving forward.
All 4,000 employees in the company are surveyed to determine. their
Where did you
workforce
see
and
it's the
job
absolute, like, where's
Over
absolute
10.
value?
It was the second question.
Yeah, but no.
No, I did the first question first. Just do the first question first. Just switch it.
Yeah.
Like, this was
Yeah.
here, and this was supposed to be there.
No.
All right, cumulative frequency. The first question is determining the employees who traveled at most 30 kilometers.
So I find 30, I trace it up,
About 800.
a little bit over 800. I can see that it goes up one more bar than 800, one more box. How much is each box worth?
Wait, 20? 20?
It's not 20.
100? Is it
150?
200?
It is 40. Do the math, stop guessing.
It's 800 by 20,
Okay, so
Like 800
each box of 5 is 400. Right? And then you do 400 divided by 5. is 8. So this would be
840. Why? Didn't you say each box was 40?
Yeah.
And so if that's one box of
Yeah.
like 800.
Yeah.
It's 840.
Yeah.
Yes.
Just want to go.
Yeah, don't laugh at me, guys.
Okay, what's the next one?
More than 80 kilometers.
Okay, so here's 80 kilometers.
The answer is 400.
How did you figure it out?
Well, there's 4,000 people. And then when you look at 80, there's 3,600 that didn't do, or less than 80. So then you subtract 4,000.
Wonderful.
Whoa, what?
All right, this is a cumulative frequency graph, meaning that the people who did up to 80 miles but did not go over 80 miles was this value right here, which we know is. But they wanna know how many did more than that. The total number of employees was 4,000. Subtract 3,600, you get 400.
Can we go to the one, the 30, like on those 30 points?
You have to find the thing.
At most, do it again.
Yeah, can you do
One
that?
second, please find 30.
It's right here.
Yeah, you're looking at.
Okay, and then each box here is
That first line above
400,
How that works? Because
Okay.
right?
400
Okay.
boxes on it.
And then divided by 5 is 80, so you should get 880.
You mean,
It's 880.
Oh,
Did I say 40?
You told me it was 40 per box.
Guys. No, I didn't. I said the math out loud, and then I just didn't hear myself.
Ms. Thompson,
We can go back to the first question.
Ms. Thompson gave us a run.
It's so off. All right, for the first question, in order to get here, we have, here's 400. I think I'm even wrong from there.
It's E, it's
No, all right. It would be approximately 880.
Okay.
How?
And then what the second one?
There's
is?
box.
All boxes and then.
Each box.
Each box, you have 400 for 5 boxes, so if we're counting up each increment to get up to 400. And then it's like one box above 800.
Okay, so they have to.
80.
Oh, that, yeah.
Okay.
I thought it ended at the 8.
It's hard to see on yours, which is why I think they give you some room for error. Because I think it's actually shy of that line at that value. Like it's not even quite up to the perfect intersection. So they probably accept anything between 800 and 880. And 880.
4,000.
Woo!
4,000, 4,000.
Sorry. The next one. I don't have the question for me.
Calculate the approximate minimum distance traveled by the top 30% of employees.
Okay, top 30%. So what is 30% of 4,000?
1,200.
Okay, so my top, I'm gonna subtract it.
what I'm saying.
You're telling me you can't do this?
I'm just playing. You just multiply it by 3 and then use the decimal.
Okay, so that would be right here. Which is a little bit above 60, I would say. So like 61 or 62.
Okay, these are on your formula sheet. Do I need to do them?
No,
Yes.
we're good. No.
No.
Wait, yes.
No.
Okay,
On your formula sheet, what's the formula for A union B?
For the
Did they give it to us?
I'm sorry, let me even make this easier. You don't need to figure out with the formula. What did you say? They didn't exactly give it to us because that little apostrophe means something. What does that little apostrophe mean?
Complementary.
It's the complementary. How do I find the complementary?
1
One
minus.
1 minus 0.2. So what would just the union be? Okay, the intersect. I'm asking, not telling.
Like 2.
It's one of the formulas on your formula sheet.
It's gonna be P, so it's 0.4 times 0.5.
0.2
No.
Wait, what did you just call
or
it?
0.0.
It's
Combined events.
It's P times P probability rate. not
Is it
probability.
0.1?
No.
Yes.
Yeah.
What, I can't, is it minus plus? Plus.
Wait,
Wait, it's multiplied.
Multiply.
What?
Combined
No.
events, Ms. Thompson, combined events is minus the probability.
Independent events, PA under, upside down UB is equal to PA times PB.
Backwards.
I have A union B is equal to the probability of A plus the probability of B minus that probability.
I have it
I have a
equal to
question.
A times.
What's the difference between, because on here, one of the formulas that says like P intersect P of A.
She's just doing the
is
one,
equal
the,
to-
like the formula to find the union,
It's like, what's the difference?
and then like using the other one.
But
You know what the
when I
union
know I
is.
need to use combined events versus.
It's the combined, because
I would say that normally it would tell you, but it is 0.1.
So is it just like a hit or miss? Like, do you just?
I would say that normally the question would tell you. I can look and see if I can figure out a reason why, but normally I feel like they say these are independent events.
Okay.
I would assume that they're not independent events until a problem tells you
Okay.
these two events are independent, calculate blank. Okay, so then for the last one, it's also the formula on your formula sheet. The final answer for that one is no. Did you do B complement?
Is that the one minus?
What's
Yeah.
again?
What?
What's B? 0.5.
So for your given, you have probability of A intersect B, and in this case, it's the complement equals, I lost my question, over the probability of B complement. Probability of B complement happens to be 0.5. So since it's the same thing, that means I could also just use the intersect of B, which we just found for part B was 0.1.
On our formula sheet, I thought it says like the intersect
It does,
divided by probability B.
it does.
I got it.
So why
So
did you put
what's
the
E?
little apostrophe?
Because in this problem,
I
it
got
has
0.2,
the
but-
apostrophe.
Oh,
But I'm saying in this case, probability of B Complement? is the same thing as probability of B.
it'd be negative.
No,
It would be negative, though, right? Because you do 1 minus.
You can
1
have
minus
it.
0.5 is
Oh,
0.5. So then I have 0.1
0.4.
divided by 0.5. Maybe.
Yeah, that's what I.
That's what I did.
Wouldn't it be 0.9
Yeah. They did something. That is how I would do it, whatever you get with that.
I got 0.2.
I'm determining that I'm correct and that this answer is. I don't know what they're
If we
doing.
were doing it with
But
the
then 1
apostrophe for that one,
minus
next question.
What?
If we found that the upside down U, I don't remember what.
It's 0.8.
That, with the apostrophe, that means it would be 0.9, right? Because it's complementary.
No, you're saying this complement.
Yeah, and is that.
That's not the same thing as this.
Oh, okay.
He's all like.
so you use a little complement for the probability.
You would find the intersect with B prime, which happens to be 0.5.
It'd be it's the same thing, because 0.5 is.
1 minus 0.5 is 0.5.
Okay.
I'm confused.
It's possible they have a typo in their problem and meant to put a parentheses out or an apostrophe out somewhere. But this is, as it is written, the correct answer.
So would you just leave it at 0.5 or 1.1 over?
No, I would,
0.2.
But isn't there an apostrophe?
1/10 over,
No, because this matches 0.5.
why is it not rating?
Wait, Ms. Thompson, why is it not 0.2?
And then keep changing.
Like 0.2 over 0.5? Because like, I thought the complementary
It
of,
would be equal to 1 over 5.
I am here.
0.2.
no, but what I'm saying is like, when you have to find the complementary of the intersect, yeah, can we find the intersect of 0.8?
Okay,
And
you're
then-
asking what Wamsi is asking. You're saying the probability of A intersect B. This says the probability of the intersection of A and the complement of B. You're saying the complement of A intersection.
But then how would you?
Okay, so how would I find B complement?
We know it's 25.
Are those two numbers the same?
So
So this and this are the same.
Right, so then it's.
So it's 0.1. So I use
I'm
0.1.
one of your best, Rocky, though, right? I'm not gonna give you.
I get it, but I don't have
Okay, we'll come back.
All right, I know this is a lot, guys. We are almost done. What's up?
Last question.
What if the probability of B is not 0.5? How are we finding the intercept?
You'd have to reuse the formula from above and repeat the same process.
Is it the combined events?
Yeah, the sum one. Yeah, combined events. That is the one I was.
The factors A and B was.
0.1. Determine the number of different sets. This one's a little tricky.
They have 5 positive integers. They always have a mean of 7, a median of 8, and a single mode of 8. For example, 2 such sets, they give examples. Okay, we're gonna break this down by pieces. I'm gonna start at the end because that's easier. A single mode of 8. What does that mean?
There is only.
I saw Tomas's hand first. Go ahead.
So, the only mode possible can be
The only mode, but what is a mode?
8. There's multiple numbers of 8.
There's multiple numbers of 8, and that means that no other number can have the same amount or more. Meaning that every number I could have, what's the minimum mode I could have? 2, right? Because I have to have more, so I could have an 8 and an 8. And so the combinations that I could have are X, Y, 8, 8, Z. Because the middle number, because it's a median of 8, the middle number always has to be 8. Okay? I also know, go ahead.
Couldn't it also be X, 8, 8, Y?
It can, you're right with me. So it could also be X, 8, 8, Y, Z. In both of these 2 cases, I also know that my mean is 7, meaning that X plus Y plus Z plus 16
You have to be 35.
would have to be 35. So that also means that X plus Y plus Z in these cases would be equal to
19.
35 minus 16.
Okay.
Okay, so from here. In these 2 cases, are there any numbers I can plug in for X, Y, and Z that correspond with this order that could equal 19?
1 for X, 2 for Y, and 16 for Z.
What does that mean?
Yeah.
Well,
You go.
We're on our last question.
Technically, yeah.
like, would not work.
For the first one, sorry, for the second one, is there anyone? For the second one, there's no combination of numbers that works here. Can you think of a combination of numbers that works there?
Because it can't be a.
Okay, if I have to have a number that's greater than 8, what's the smallest number that I could have that's greater than 8?
9.
Couldn't it be?
What's the next smallest number I could have this very many, because they can't be the same number, right? That's 19. I can't have zeros,
Miss-
now it doesn't work for
Miss-
19.
Yeah, couldn't it be equal to 8?
Yeah.
Couldn't it be equal to 8?
That's a different scenario. I said with X, Y, and Z, where they're not
Okay.
0,
0 is not a positive integer.
0.
Okay,
8.9.
all right, so from here, now I have these combinations where I could have, methodically going, I would start with 1 here. So I could have 1, I can't have another 1, so the next smallest number I could have is 2. 8, 8, and then what would be Z?
16.
Now, in this case, I don't have to figure out all of the combinations, I just have to count them. So I could have a 1, 2, a 1, 3, a 1, 4.
That's a lot.
What's the smallest number I could have on the other side of 8?
9.
Okay, so I could have a 9 here, and if I have a 1 here, what's my remaining number?
9. No, can't be. Can't
So
be.
that doesn't work, so let's pick a different number. What's the next smallest number I can have over here that you think?
10.
Okay. Do you want to maybe,
You said 12.
if you choose 10,
Can't be 10 either.
okay, thank you.
Let's just jump to 13.
Let's go with 11.
13.
11. All right, so when I plug in 11 and I plug in 1, I have 12, which leaves me with 7. That is the next smallest one. So I have an option with 11, 12, 13, 14, 15, and 16. So here I have 1, 2, 3, 4, 5, 6 options for this format with a 1 in front. Okay, with a 2 in front,
Oh my gosh.
We have to do it like this for everyone?
this is
Yes.
the easiest way for y'all to do it until you see a pattern. And since every pattern is different, unless you just so happen to get a pattern that you recognize, it's just gonna be easiest to.
One good thing, there's 14.
It's 14 points for a reason.
You
Okay.
know what, you're right.
So if I have a 2, can anybody tell me what this, I could have a 2, 3, and then what would be the biggest number?
14.
Okay, what do you think this, if I have a 2, what would be the smallest number I could have, do you think?
10.
10.
Okay, when I count it up, I have 11, 12, 1, 2, 3, 4, 5.
Wouldn't that have to be an 8?
No way.
Wait, Ms.
Never mind, never mind.
What?
Did the pattern just 6, 5, 4, 3, 2, and then it stops at like 6, so 6 plus 4 plus 3 plus 2.
Okay, so then you think you see the pattern. Do y'all want to keep checking it or do you want to trust the pattern?
I trust
I don't
that.
trust everyone.
2 numbers and you trust a pattern?
I don't
Oh,
trust.
no,
everyone.
I just don't feel like doing the damn work.
I don't trust everyone.
Okay, well, let's check a
Yeah,
different
same.
number than maybe at the end of the list. What's the greatest number that I could have
7.
for X,
8.
if I don't want X or Y to be
6.
6? Okay, so I could have 6,
Wait, no,
7.
that couldn't work.
Wouldn't it be 5?
13.
Because that couldn't work.
Oh, that didn't work. How do I know where to stop? That's my question for you. So then what's my next highest number?
5.
Okay, if I do 5 and
That
6,
Also would not work.
okay, so what if I do 4 and 5?
4
4,
and
5,
5
10,
could work. 4 and 5 works. 4, 5, and 10, right?
No,
No, 4, 5, and 11.
okay, sorry.
No, 4, 5, and
No.
4, 5, and 10.
Okay, that is the last one. But there's no other numbers that work for 4 and 5, right? Okay, so this is 1. So then my 3, how many combinations? Oh, wait,
3.
did it follow the pattern?
No.
Yeah. No?
I'm so confused.
Yeah. Absolutely not.
No.
What is 4, 6, and 9?
What is
Yeah.
Oh, does it just go up?
Keep going. 4, 7, and 8 is the other set. Right?
That's a weird pattern.
It goes 6, 5, 4, 2.
Okay, but we need our 3s, so go ahead and do your 3 sets.
3, 4,
3,
12.
3, 4, 12, 3, 5, 11, 3, 6, 10, 3.
This one's 4, right? There's 4 of them, 3s, I'm pretty sure.
Good job, Andrew.
2, 3, 4. Yeah. So I have 6, 5, 4, 2. Add all of those together. I have 13 permutations of this form.
Next form.
Okay?
Then put an 8 where Y is.
How would you do that? Wait, so Ms. Thompson, you got 6, 5,
Because-
2, right?
I'll tell you.
That's why we don't trust patterns.
So,
So we don't trust robots.
Hey. I'll throw on your pattern.
I thought that was implied, we don't trust them.
Okay,
if we put an 8 for Y, there's only 2 options.
so if I put an 8 for Y, you said,
Yeah, there's only
so I could have,
those options.
sorry, 3.
1 and 10. You're on 8, 8, 8, 10.
I have X, 8, 8, 8.
Yeah, there's 2 options. There's 1 and 10 and 2 and 9.
So I have 1 and 10 and 2 and 9.
And then X, Y, 8, 8, 8 wouldn't work at all.
No, X, Y, 8, 8 does work.
It does?
Yep.
Oh, yeah, 6 and 5, 5 and 6, 5 and 6.
And
5 and 6, and
4
4 and 7.
and
4 and 7. 2 options. And then if you have 4 8s, then you can do
You forgot the other
3,
one.
8, 8, 8. So there's 1 option.
You forgot the 8, you forgot the 8, 8, 8. Y is it?
Nothing could work for that one.
8, 8, 8,
We already,
8,
we already did that. There's only 1 option, right? Because it has to be a 3. 18 options. Is that right? Are we missing some?
Absolutely.
we are missing 1 somewhere.
21.
Hang on. Yeah, wait, what did you start 21?
Yeah.
Yeah, it's 21.
It was just all 8.
So to do
Because something, it's not 13 options. It's 6 plus 5 is 11, plus 4 is 15, plus 2 is 16, plus 5. So yeah, that the only thing that goes up is a 13.
Oh, shoot.
That is the end of class. What minutes?
It's 16.
16?
Yep.
I just can't math.
All right, I know that was a lot.
I strongly encourage you to pick up problems sometime today to take home. I encourage you to do 1 ID problem at least a day. Not just the days that you have these, but every day. Secondly, if you are interested in another paper 1 for statistics, raise your hand.
Another way.
Another paper 1 for statistics. 1,
Oh,
2,
yeah.
3, 4, 5, 6, 8, 9, 10. Okay. During lunch, I should have them printed out. All right. On the, put your formula sheets on the table on your way out.
Bro, I fell asleep in an hour. That's not right.
No,
No, I'm thinking.